connection.
Hello, this is Elijah Rose and Caleb Crocker with Alarm Bees, a EE490 project in 2024. In our project here, our goal is to have synchronous alarm clocks in order to transmit information to the cloud and receive it from another source. To that end, we had this due to a certain problem with one of our raid members. Caleb?
Yeah, so we used to be in a raid group that raided at specific times and days of the week. We have a certain member that would always be asleep at the time we're supposed to raid. So our project is a solution to that problem in being an alarm that flickers lights and emits sound to wake the person up on command.
And that is exactly what we tried to do. Um, For this, we decided to start creating ideas on how we would construct a hardware capable of this. Here you can see our initial idea on how we were going to set up two different devices in order to connect through the Arduino IoT Cloud and share a same state variable in order for both to reflect the same alarm state. We have various modules, a switch as a read device, and a various outputs devices such as a piezo uh, passive buzzer and an LED in order to hopefully alert the other person of a time to raid.
Yes,
But
and
this, sorry.
I can go into the code now to show you how it works. So right here, I'm going to try to keep it simple and just very high level with my explanation. So right here, we have all of our variables, statuses, times for intervals for the alarm and for debouncing. We have pin assignments. In our initial setup, we do all of the basic stuff that you do. Then we have our initialization of our pins here for the LED and the button. Um, Next, in our main loop, it follows a very simple loop. So it checks to see if the button has been pressed, and if it's different from what it was previously read, checks the interval to make sure that it has been debounced. And then if it does debounce correctly, we toggle the alarm state to on or off. Next, in the loop, it'll check if our alarm state is on. So if the device is supposed to be making noise and flashing lights, um, we have a timer interval, so it turns on and off every 250 milliseconds. And then we either toggle the LEDs on and the buzzer on, or toggle them off if they've been on for 250 milliseconds. So a couple of the challenges we came into while we were programming this is the status of the switch. We initially thought that it would be a 0 as long as the switch is not pressed, and then a 1 as long as the switch is pressed, but it is a normally closed switch, so it is high unless it is pressed. Once it's pressed, it's low, so when we first initialized the switch, it gave us some errors. And by some errors, I mean it started the alarm as soon as the board initialized instead of starting the alarm turned off. So we switched all our variables to high to solve that problem.
We additionally ran into errors with the ESP32 board, which I have right here. Um, While the Arduino 4 works seamlessly with the Arduino IoT Cloud and the ESP32 is technically supported, there was a pretty major bug in the Arduino IoT Cloud as of the time of this video that has persisted for the last couple months. I believe it is supposed to be solved relatively soon. Um, Additionally, it cannot support 5 gigahertz internet. Most devices are not able to support this. And in order to get around this, in case you run into this issue with your own projects, you want to use a compatibility mode in your device to set up a hotspot that then forces a 2.4 gigahertz Wi-Fi network. This is what many lower end devices or lower power devices run at as a better means to get through walls and more reliable connection.
Mhm. And the another final challenge that we had in setting up our project is the Arduino Cloud, which is what we use. What is this IDE and everything that we use to set everything up? It is not compatible. At least the free version is not compatible with multiple boards. So you can only use one board in one project. So our solution was instead of having a transmitter and receiver, as shown in our diagram, it is all done from this transmitter board. So it transmits the data to the cloud and then activates it on its own. So there's no additional board that simply reads from the cloud and transmits the signal. So now that we looked at the code, let's send it to the board. It's going to take a second to compile, but simply we press the button and then the alarms are here. I will move my camera down to show you the board. When we press the button, the speaker and the light will start turning on for 250 milliseconds and then turning off. So every quarter of a second, we just flash our lights and our sound. And then when we press the button again, it will turn off and stop transmitting the alarm. And as you can see, we've got pins 2, 3, or 2, 4, and 6 for the light button and the LED. All right, so it has submitted, verified, everything is good. And as I said, we solved the problem where nothing is going off as soon as the board initializes. Now when we press the button, the light starts blinking, the sound starts going off. We press it again, and it turns off. And to show the dashboard and the IoT functionality of it, we also have a switch on our dashboard, and this essentially just works as the alarm state variable that tells whether we should be having an alarm go off or not. So our alarm is off right now, and then if we switch it, starts going off, turns back off. And we can turn it on here, turn it off here. It might take a second to update on the cloud. Then we press it again, and then toggle it off here, and it should turn off.
It may be a Wi-Fi connection issue.
Yeah, it may
I
have
ran into some of
disconnected
those
from it.
with. When you look at the serial log, sometimes it will connect with the internet and then it'll disconnect and then reconnect,
Hmm.
uh, which
There it goes,
sometimes
working
happens on lower
again.
end devices.
Yeah, a little bit buggy, but it's likely there we go, just due to the Wi-Fi connection itself.
Mhm.
So we turn it on the dashboard, press the button, turns off. Just like that. So that is our project and how it works.
To go over the course itself, um, I learned a lot about the microcontrollers and microprocessors and the differences between them. A microprocessor would be something like the Raspberry Pi here, whereas a microcontroller would be something smaller like an ESP32 or the Arduino board. And these are used in a lot of our devices, from little toys or from sensors or cameras. And so it's great seeing the inner workings of there. I also had a lot of fun, and one of the highlights of the course for me was creating my campfire code, which was setting up a bunch of various little devices from a joystick to a LEDs and a little buzzer, all to mingle together and being able to read and write seamlessly through the Arduino board. Having the plug and play functionality work so seamlessly in this day and age is quite a delight.
Mhm.
Clip.
And for me, my highlights were learning to use the Arduino boards because in previous courses we used different microprocessors and they were typically really old, but they still had a lot of functionality. And these boards, while they also still have a lot of functionality, they're a lot more straightforward and simple to learn how to code. So it was really neat and easy to figure out how to use them, as well as all the different devices that came with that starter kit. We had all kinds of different devices like buttons, switches, all that kind of stuff.
And that would conclude the Alarm Bees project with Elijah Rose and Caleb Crocker. Thank you for tuning in and take care.
Thanks. Bye.